What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA 1201 certification exam. So let's get into it. You're diving into the world of IT and preparing for your CompTIA A plus exam. And one of the topics that trips up a lot of people, especially if you're just getting your feet wet, is virtualization. But here's the thing, virtualization is everywhere. It powers cloud computing, lets businesses test apps without breaking stuff. It even helps developers run Mac apps on Windows or vice versa. And once you understand the why and the how, it actually becomes a very practical and useful concept. So in this video, we're going to walk through everything you need to know about virtualization for the A+ exam so that you can feel more confident on this subject and maybe even spin up your own virtual machine. So with that being said, let's go. All right, so let's start with the basics. Virtualization. This is the process of creating a virtual version of something like an operating system, server, or a storage device on top of physical hardware. So instead of needing a separate computer for every operating system or application that you want to run, you can run several virtual systems on one physical machine. So think of it like this. You have one house, i.e. your computer, and instead of building a whole new house every time a new guest shows up, you just give them a virtual room inside that same house. Now, everyone has their own space, but they all live up under one roof. That's pretty much virtualization. All right, so let's go ahead and talk about why virtualization is such a big deal. Well, here are the most common use cases that you're going to see, especially as you step into IT roles. So we have what are called sandbox environments. And basically a sandbox, this is like a safe playground for running experiments. So if you want to test out a sketchy file or run new software without messing up your main system, then that's where a VM or a virtual machine comes in handy. And you can create a virtual machine and you can do whatever you want inside of it. You can test viruses, break stuff, install weird applications, and when you're done, you can just simply delete it. There's going to be no harm or no foul to your actual machine. And sandboxing, this is basically great for cybersecurity training, IT students practicing risky commands, and for testing scripts without fear. And then we have what is called test development. So developers, they love virtual machines because they can build and test software in different environments without buying more hardware. So let's say that you're coding an app for both Windows 10 and Linux Ubuntu. Well, instead of buying two different computers, you just spin up two different VMs on one machine and test your code in both environments. And what happens is this is going to save time, it's going to save money, and it's going to streamline the development process. And then there's application virtualization. So here's where it gets even cooler. So instead of virtualizing an entire operating system, you can virtualize just the application. And this is especially useful when you need to run legacy software that only works on an older operating system like Windows XP, or you want cross-platform compatibility, such as running Mac applications on Windows or vice versa. And basically, application virtualization, it packages the app in a neat little box that's independent of the underlying system. That means fewer compatibility issues and easier deployment across multiple devices. Virtualization is great, but it's not magic. It needs a solid foundation to work properly. So let's go ahead and break down the big three, and that's security, network, and storage. And let's start with security. So virtual machines, they need just as much protection as physical machines, and maybe even more. And the reason why is because if a hacker breaks into your host machine, they could potentially access all the VMs running on it. So here are a few must-dos. One, you want to use strong passwords and authentication. You want to isolate your VMs from each other, and you want to keep everything updated, meaning your VMs, your host operating system, and the virtualization software. And don't forget, just because it's a sandbox, that doesn't mean it's immune. Malware can still escape poorly configured VMs. The next requirement is the network. So every virtual machine needs to connect to a network, whether it's the internet, a local network, or both. In virtualization software, this often gives you several networking options. And the first one is called bridged. And that's where the VM acts like its own device on the network. Then you have what is called NAT, or network address translation. And this is where the VM shares the host IP address. And this is great for internet access without direct exposure. Then you have what is called host only. And this is where the VM can only talk to the host system. And this is good for testing and isolation. So understanding how your VMs connect, this can help you configure firewalls, troubleshoot issues, or even set up test labs. And then we have the storage requirement. So virtual machines, they can eat up a lot of space. So when you create a VM, it usually has its own virtual hard disk file, which is essentially a big container where the operating system and files live. So you need to make sure that you have enough disk space for the VM because some VMs require 20 to 40 gigabytes or more of space. And you also need to choose between a fixed size or a dynamically expanding disk. And you want to make sure that you back things up because VMs are essentially files and these files can get corrupted. So at the end of the day, storage performance matters as well when you're dealing with VMs, and slower disks, they can make your VM move at a slow pace. All right, next let's talk about desktop virtualization. So if you ever heard somebody talking about quote unquote working in the cloud, well, that's often powered by something called VDI or virtual desktop infrastructure. And with VDI, basically you're not running Windows on your local laptop. You're accessing a remote virtual machine hosted on a server somewhere else. And everything that you do is streamed to your screen. And the common use cases for VDI are as follows. So they're used in call centers or help desks where everyone logs into the same VM image. You can find them in schools and libraries where you can reset sessions after each user logs out. And you'll find them in remote work environments where the tech department, they can control everything remotely. So basically, VDI makes managing hundreds or even thousands of desktops much easier for IT departments. They can do updates, backups, and implement security settings. And all of this is done at the server level. And it's not something that you're going to initially set up as a newbie at tech, but it's definitely something that you will encounter. All right, so here's a cool concept that you might have heard in developer circles, and that is the concept of a container. Now, containers, they are like VMs, but they're lighter, faster, and more focused. And instead of virtualizing an entire operating system, containers, they share the host operating system kernel, but run isolated applications. So think of it like this. VMs, these are full apartments where everybody has a separate room, a separate kitchen, and a separate bathroom. Containers are more like roommates in the same apartment who share the kitchen, but they stay out of each other's bedrooms. Now, when it comes to containers, the most popular one out there is a company called Docker. And this is especially useful in cloud and DevOps jobs where speed and consistency matter. Now, for the A+ exam, you just need to know the following. You need to know that containers are isolated environments. They're faster and use fewer resources than VMs, and they're great for running multiple applications on one system without conflicts. All right, next, let's talk about what makes virtualization possible in the first place, and that is the hypervisor. So a hypervisor, this is the software layer that lets you run virtual machines. It manages the hardware resources and allocates them to your VMs like the CPU, the memory, the disk, etc. There are two types that you need to know about. The first type is called a type 1 hypervisor or bare metal. And this hypervisor runs directly on the physical hardware. It doesn't need any underlying operating system. So essentially, it's like skipping the middleman. And some examples of a type 1 hypervisor are VMware ESXi, Microsoft Hyper-V, the server version, and Zen Server. And type 1, this is used in enterprise environments and data centers. It's efficient, powerful, and stable, but it's not really for beginners. You have what is called a type 2 hypervisor or a hosted hypervisor. And this one runs on top of an operating system like any other application. So you install it on Windows, Mac, or Linux, and then you use it to create and manage the VMs. And examples of this would be Oracle VirtualBox, VMware Workstation, and Parallels Desktop for your Mac OS. And type 2 hypervisors, these are great for home labs, training, and testing environments. So once again, the main difference between these two is this. When it comes to a type 1 hypervisor, basically when you turn the machine on, your computer automatically boots into the hypervisor. And then from there, you can go about creating your guest operating systems or your VMs. With a type 2, you turn your computer on, it boots into your operating system, Windows, Linux, or Mac. Then you have to turn on the hypervisor like VirtualBox or VMware. And then from there, you can create your guest operating systems or your VMs. That is the main difference between these two. All right, so if you're still wondering where virtualization fits into actual IT jobs, let's go ahead and look at some real world examples. So if you find yourself doing help desk support, basically you're going to be troubleshooting VM login issues, mapping shared drives and VDI environments, and guiding users on connecting to remote desktops. If you're an IT technician of some sort, you're going to be spinning up VMs to test software, build sandbox labs, or deploy legacy systems. If you find yourself as a system administrator, you're going to be maintaining hypervisors, managing VM snapshots, allocating storage, and configuring virtual networks. If you find yourself as a cybersecurity analyst, you're going to use VMs to analyze malware safely and test patches before pushing them live. And if you're going into IT, just understand that virtualization is going to be a part of the job. So understanding this early, this will give you a serious leg up in your career. Now, let me go ahead and wrap all this up. So virtualization, this can sound intimidating at first, but once you get the hang of it, it's actually kind of empowering because you realize that you don't need a ton of hardware to experiment, test, or deploy stuff. You just need the right tools and a good grasp of the basics. So here's a quick recap of everything that we learned. Virtualization. This is for creating virtual versions of hardware or software. Virtual machines, they are great for sandboxing, development, and running legacy software. You need strong security, proper network settings, and enough storage to operate a virtual machine. VDI, this is all about centralized desktop management. Containers, these are lighter application-focused versions of virtual machines. And hypervisors, they come in two types. You got type 1, which is also called bare metal, and type 2, which is called hosted. And remember, this isn't just something to pass the A+ exam. Virtualization is a real-world skill that shows up in nearly every IT role. Whether you're troubleshooting a virtual desktop or setting up a test lab at home, it's something you use throughout your tech career. Now that we've gone through all of that, are you ready to go out there and start playing with some VMs? Well, if you are, then you can go ahead and download a product called VirtualBox for free, offered by a company named Oracle, or you can download one called VMware Workstation Player and spin up your first virtual machine, and then go out there and try to install Linux on it, break it, fix it, and repeat it. Because the best way to learn about virtualization is to get in there and start playing around. And trust me, you'll be amazed at what you can do once you understand how all of this fits together. All right, so with that being said, let's do some check on learning. So our first question is, which of the following best describes a type 1 hypervisor? Is it is installed directly on the physical hardware and does not require a host operating system? Is it runs on top of a traditional operating system like Windows or Linux? Is it is mainly used for gaming performance enhancements? Or is it is only compatible with Mac devices? And the correct answer is it is installed directly on the physical hardware and does not require a host operating system. So a type 1 hypervisor, also known as bare metal, this runs directly on the physical hardware without needing a host operating system. It is commonly used in enterprise or data center environments for its efficiency and performance. Next question. What is one key difference between a virtual machine and a container? Is it VMs use less system resources than containers? Containers that require a type 1 hypervisor to run? VMs virtualize an entire operating system, while containers virtualize individual applications, or containers cannot be used on Windows systems. And the correct answer is VMs virtualize an entire operating system while containers virtualize individual apps. So VMs, they emulate an entire operating system, including the kernel, while containers are lightweight and virtualize just the application and its dependencies while sharing the host system's operating system kernel. And our final question, which of the following is a primary reason to use a VM as a sandbox environment? Is it to permanently replace your physical operating system? Is it to save power by turning off your host computer? Is it to improve internet speed by virtualizing your browser? Or is it to safely test software or files without risking the host system? And of course, the correct answer is going to be to safely test software or files without risking the host system. So a sandbox VM is used to safely test potentially risky files or software without harming the host system. It provides an isolated environment where you can experiment and roll back changes if needed.